have to start the parallel circuit. We have done the introduction series. Now we have to do the parallel circuit. So do you have an idea of the parallel circuit? Do you have?
Yes. In
Okay.
parallel circuit, more, more than one cable used.
Your voice is low. Can you speak louder?
In parallel circuits, there is more than one cable used.
Yes. And parallel circuit is an electrical circuit where the components are connected across the common points, creating a multiple path for the current to flow. And this is in contrast to a series circuit where components are connected end to end in a single path. Here's a concept that every component is connected end to end point. There are multiple paths for current flow, and this current is divided and voltage is same. Every bulb is getting a different current. For example, if this first bulb is getting more, this is less, and this is smaller, and each of the bulbs are getting same voltage. Okay,
Okay.
so we are going to explore the parallel circuits, and in particular we'll consider how they treat potential difference. Okay, current and resistance. Parallel circuits are those with more than one loop. Okay, and generally each loop will only contain a single component. You cannot place a two more than one component in a single wire, same as like as shown in the picture. Okay, each loop contain one component. Okay, this makes a parallel circuit much more useful than series circuit. Because as such component has its own loop, if any particular component breaks, then the overall circle is still intact. For example, if I just switch off the first bulb, switch off, I open that switch, do you think the second and turn will still bright up?
Yes,
Yes, very
because
good.
there's still uh,
Because current is the divided, na, and the voltage is the same. For example, if one of the lights in your house blows, and all of the other one will still work, although often two circuits will be a mix of series and a parallel parts. So although we might have multiple loops, we could still have more than one component in some of those loops. So if you're not sure what series circuits, then it's probably I explain everything. Okay, now the first thing to know about truly parallel circuits, so those with the only one component in each loop, and in that all of the components get their full source potential difference. If we have a 12 volt of battery, just imagine that if we have a 12 volt of battery, then all the components will have 12 volt across them. This is a 12 volt of battery. This bulb has 12 volt of potential difference and 12 volt of potential difference. Got it? And the next thing to know is that the
how
current is shared between.
doesn't
Yes.
it divide between of the component potential difference?
Yes,
Doesn't it divide? So then why would both bulbs will have a potential difference of 12?
exactly. So if the circuit with two
Uh,
loops,
why do they both have a potential difference of 12?
I do you asking the question?
Yes.
And the question is,
Why both of the filament lamps have a potential difference of 12 instead of being divided?
because this is a parallel, na? The 12 volt of current is 12 voltage. The source is 12 volt, na? Then the each bulb has the same volt. Then each bulb will have 12 volt, 12 volt. The current will be divided. Maybe 6 into 6, or maybe 10 into 2. Okay, maybe 8 into 8, 9, 10, 11, 12, maybe 8 into 4. Current will be divided, voltage will be same for each bulb, each component. That's why I mentioned 12 and 12. Okay, Understood?
Okay.
Did you get the point?
Yes.
Okay.
Yes.
And look here, the voltage is same. V1, V2, V3 is equal to V total. You don't have to use V1, V2, 3 again because this is all equals to V total. And then next thing is, now the potential difference and the current is divided. And what is the formula for the resistance? That is V by I. Then it will look like R is equal to V by I1. Look here, 12 volt current is same, voltage is same, and then the current is 2 ampere, 2 ampere. They're just using and set an example. You can use any other example, okay? And the two have 2 amperes flowing through loop. Either way, if we add the current in each loop together, it will always add up and to the total current of the circuit, in this case 4 amperes. The way that the current splits will depend on the resistance of the individual component in the circuit, with the loops that have greater resistance taking a lower share of the current. Okay. Now the parallel circuit loops that have the greater resistance taking a lower share of the current. Or the loops, the wire that have the greater resistance, they will have a low current. Why? Because resistance is inversely proportional. Resistance increase, current will be decrease. Current increase, resistance will be decrease. Okay? Did you
Okay.
get the point?
Yes.
For example, you can think of this as if the current water is flowing downhill. If the water can flow down two possible paths, then most of the water which represent electrical current will take the path of least resistance. If this is the path of current which has more water, it is more current, resistance will be least. Low current, resistance will be maximum. The simplest example of resistance and current. Okay. Okay. Now the parallel circuits and the same example, look here. Okay, in the third example, the last thing we need to look at is the resistance. One strange thing about a parallel circuit is that the more component we add in a parallel, the lower the total resistance of the circuit will be. If you are going to add more component, then you will get a lower resistance. It is a pretty odd concept that it could be just one of those facts that you have to accept and remember. But it might help to think about in terms of our river example. Imagine that we add another possible route of water to flow, even if this route has a high resistance, and it will increase the option for our water flow. Look here, this is the highest resistor because it has very slow path of current, very narrow path. Okay, meaning that the
So
water can flow
I would
down.
say that if the cross-sectional area of a wire is
Area,
huge,
yes, an
then
area
it will
is
have
increases.
middle.
In the middle one, this is the path, like a broad path, na? Broad path, more current, low resistance. In the second picture, that is a narrow path, narrow current, more resistance. And again the narrow path, smaller current, more resistance. Okay, this one is the least path of
Okay.
resistance. This is the highest and this is the most highest. Okay, understood?
Yes.
Do you have any question?
No.
Then you can use a formula here. Then the total resistance for the parallel is like this: V by I1 plus V by I2. You have to write it down, okay? V by I3. Then here it will become R T is equal to resistance 1, resistance 2, resistance 3. Okay?
Okay.
And I already shared this PDF with you. You can use this PDF for revision test. Okay.
Okay.
Do you have any question, Ayan? Okay, we have to start the topic of charge. A measure of a total current that flowed with a certain period of time. Okay, certain period means the time. So charge is basically the current is flowing in a closed circuit in a time, in according to interval time, that is known as charge. And the charge, the unit is coulomb, and I is ampere, and time is seconds. Okay, so this is a total amount of water that was flowed down the hill within a certain time, hill. And this is the same example we did in the last lecture. Okay, so we are going to be really quick on to go over what charge and the equation that we use to find. If we go for the definition, first, charge is measured for the total current and that flowed within a certain period of time. So if you are familiar with the water analogy, where current is rate at which water is flowing through the river, then the charge would be the total amount of water that flows downhill within a certain period of time. Okay, but look at this is the two parts of the water, the middle one and then right one. Both will have the different interval of time, both will have the different flow of water, and the flow is basically current and the time is the period. Okay, like a minute or an hour. We represent charge with the letter Q and is measured in coulombs, which we show with the C. The equation to remember, okay, is the charge equals current measured in amperes and multiplied by the time measured in seconds. So the question might look like this. A kettle draws, for example, the question will be like this, okay, for your exams point of view. A kettle draws a current of 12 amperes and take 50 seconds to boil. How much charge passed through the wire? We have to find the current. We have to find the charge. And charge is measured in coulomb. Okay. I'm talking about this example. And we are ready to given that the current in amperes, the time in seconds, and we do is to plug the numbers into the question as 12 times 50, which gives us 600 coulombs. Okay, so the two things, that current is given and then time is given, we have to find the charge. Then Q is equal to IT and the charge will be find. Okay, for the another question on the next page. Here. Okay. For another question, a phone charger transfer a total charge of 43.2 and kilocoulombs over a period of 2 hours. What current flow through the wire? First, we need to look at our equation because we are trying to find the current, na? And current is on the opposite side, charge and time is given. So we're going to have to rearrange it in a form, the right form, by dividing both sides by time, and this equals us this gives us equals Q over T. Okay, we're just switching the places. And next we need to convert our units to get coulombs in seconds. So we need to multiply 43.2 by 1000. Okay, and to give us 43 to 200 coulombs, and we need to multiply our 2 hours by to get 120 minutes. Remember that the time is in hours and that this is kilocoulomb, because if the data is given like hours and data is given like coulombs, the thing you have to remember here, the charge is always in coulomb. You have to remove that kilo, and you know that when we have to remove that kilo, we just have to multiply 1000. And when we have the hour, the time in hours, we have to convert the hours into seconds, divided by the 3600. Okay, and the next thing, now look here, 43.3 kilocoulomb multiplied by 1000 will become 43,200 coulomb. 2 hours, 60 minutes, 120 minutes, 60 into 7200 seconds. Okay, and then lastly we do have to plug the numbers and in and do 43,200 divided by 7,200, which gives us like 6 amperes. Okay, in the next, I think, yes, 6 ampere. By dividing these two quantities, the answer will be 6 ampere. Okay, so this is how you can solve the formula. If you have ampere, if you have time, you can find charge. If we have charge, if we have current, you can find time. If you have time and charge, you can find current. Got it? Any question in the topic of charge?
No.
Very good. Should we move to the next?
Yes.
The Ohm's law. And you know the idea of Ohm's law, like little bit information and the knowledge about the Ohm's law, isn't it? Yes. So one thing I told you in the last class, that Ohm law is like V is directly proportion to the,
Current.
yes, V is directly proportion to the current. So how this thing happens? This thing happens like when we have a direct proportion, we have to remove the direct proportionality with the constant, and we use the constant that is, we will use the constant that will be the resistance, and resistance is used in the Ohm's law to oppose the current, to oppose the flow of the current. Okay, so look at the equation V equals IR, and at some important current versus potential difference graph. These are the three different graphs which shows potential difference. This is a graph between the potential difference and then current. The first graph is the best example of Ohm's law, because these are the materials, conductors and resistors which follow the Ohm's law, and other two are not ohmic materials because they don't follow the law of Ohm law. And these are maybe conductors or maybe resistors. Okay, so you just have to look, that's how we can draw the graph. Okay, how we can draw the graph. This is a basic idea how you have to draw the graph. Okay, now the next thing, just we have to how they will tell the explanation how we can use this formula. Basic. So what is the proper definition of the Ohm's law? Yes. Okay. Ohm's law states that the current flowing through a conductor between 2 points is directly proportional to the voltage across the 2 points, provided the temperature remains the constant. You have to write this definition. Okay, you have to write this definition, and then you also have to draw this formula as well. You have to put the topic Ohm's law, and then you have to write the definition. Done with the heading? Now I will speak and you have to write. Can I speak?
Yes.
Okay.
Yes.
Ohm's law states that the
Ohm's law states
that the current
that the current
flowing through a conductor
flowing through a conductor
between 2 points is directly proportional to the
is
voltage across the 2 points, provided the temperature remains constant. And one thing you done है यार, तो कहाँ से बोलूँ? Provided the temperature remains constant. ठीक है? Okay. So you have to write the formula like step by step from where this formula is generated. Okay, I'm gonna write here V is directly proportional to current, and for removal of this directly proportion we put the R, and R is the resistance, and this is the, you can say this is also the law of Ohm's law, and this is the formula of resistance. Basically V is equal to I is Ohm's law. Okay, don't you think that this is the Ohm's law? This is the resistance formula. Okay, you have to write these three things after the definition. When you're done, let me know, then we will start. Okay, done. Okay, so important equation in the electricity topic stands for the potential difference of the voltage equals current, time, resistance. Because if you're going to study about the Ohm's law, then you must know these three things, because these three things only use in Ohm's law, isn't it? Yes. Okay, basically in the Ohm's law, if you increase the voltage across a conductor, the current will also increases. Remember this thing. If you are going to increase one term, another thing will also be increases. When the two things increasing at the same time, then the graph will be the steep slope, a gradient. Okay, and then the voltage for our cell must be 4 times 2. This is an example, 4 times 2, and is 8 volts. This will be the voltage. For another example, if we had next example, if we had 24 volt and which was producing by the current of 8 amperes, then to find the resistance, we have to rearrange our equation to R equals V over I, and then do 24 divided by 8 to give 3 ohms. Okay, so this is the idea about the current and ohms. Now the current and potential difference, how we can use the current and potential difference in Ohm's law. Okay, so the relationship between the relationship between voltage and the current and the resistance, as long as the resistance stays constant. So this is the graph. This graph will shows you that if the resistance is constant, then if the current is decreasing, then the voltage is also decreasing. आप देखें अगर वो एक स्ट्रेट लाइन ऊपर जा रही है तो नीचे वाली भी वैसे पहुंचती बिल्कुल स्ट्रेट लाइन हो जाएगी. ठीक है, अगर एक स्टेप इंक्रीज हो रहा है तो दूसरा भी इंक्रीज हो रहा है, अगर दूसरा डिक्रीज हो रहा है तो वो भी डिक्रीज हो रहा है. ठीक है, as long as the resistance stays constant, then we increase the voltage, the current should increase proportionality. वही बता रहे हैं, if the voltage increases, the current should increase proportionality. If the current is increases, voltage will also, the voltage, the current will also, and the vice versa. So we can see if we plot a graph of a current against potential difference, as the potential difference increases. For example, we use a bigger battery, and the current reduced in the circuit would also increase. Okay, and this negative part down here just shows the same thing except the battery. Okay, so this part, this is a negative part, this is just showing the current. There is no battery here, this is only wires. This diagram is just drawn to give you an example to understand the concept of Ohm's law through the graph. Okay, so if you are going to do like this, this is a graph, and I hope Ayan, you know how we can draw the graph. You know that? If you need explanation, you can ask. Okay. So basically, I will change the different color to show. So if the straight line, then it is again bending, and then again, and then it will become a straight line, simple straight line. Okay, so is attached the opposite way around, and so the voltage current are effectively negative. When they are going negative, both will go negative. Both are positive, both will be positive. Okay, we get this nice straight lines in the circuit that contains only wires, resistors, because for these circuits the resistance stays constant the entire time, which remember was the requirement. We mentioned earlier that if we use a different wire or different resistor, the line would still be the straight, but it would be more or less steep. For example, bigger resistor would have a less steep line. In the next example, red lines. I have drawn that red lines. Okay, like this for 10 ohm resistor. For example, a bigger resistor would have a less steep line. The first picture is with a smaller battery and it has a very good steep line. In the next picture, they have a very large battery, 10 ohm, 6 ohm, 2 ohm, and every ohm the current and the voltage is the same, and this is the result of the resistance. Okay, while smaller resistor will have a steeper line. You can think of this in terms of how much potential difference is required to produce a given current if the circuit contains a smaller resistor, so less overall resistance. Then we only need a small potential difference, because if the resistance is more, then we just need a small amount of potential difference to draw this kind of current in the circuit. If the current is smaller, potential difference will also be the smaller. Okay, difference to drive a large current. One thing to mention here is that we are assuming that the temperature stays constant. Temperature is constant, no? One thing to mention here is that we are assuming temperature is constant. If we increase the temperature, what will happen if we increase the temperature? Okay, assuming temperature stays the constant, then the resistance would also increase. This is the important point, that temperature and the resistance have the direct relation. Temperature and the resistance have the direct relation. If the temperature increases, resistance will also increases. Okay, so in reality, higher currents do generally cause wires to heat up if they are left on for a while. So in practice, the lines don't always look quite this straight. If the temperature increases, voltage increases, current start flowing fastly, and because of that the circuit will get heat up because of the higher temperature. Is it? Let's took an example of filament lamps and diodes. Okay, filament lamps and diode. This is the example of filament lamps and diode. So the next thing we need to look at are the graphs of filament lamps and the diode. Filament lamps are just light bulbs. This is an example I just giving you in the previous class. This is that bulb that we used in the previous time. This is a light bulb, orange or yellow bulb. Okay, filament bulb इसे कहा जाता था filament bulb. Okay, filament lamp are just light bulbs which contain a very thin metal filament. As the current flows through the filament, the wire heats up and until it's hot, then it emit light. इसके अंदर इतनी छोटी छोटी सी ना लगी होती हैं फिलामेंट वायर्स होती हैं, थिन वायर्स होती हैं, and that three wires are connected with each other with the thin wire again. That thin wire is known as filament. When the charge start flowing in that filament, it gets heat up, and when the temperature rises, the current moving very fastly, and it just start emitting light. It's blow up, it gives light. Okay, and this is the concept of filament lamp. Filament lamp wire heats up, so it's hot, and all of its heat massively increase the resistance, so the curve gets less steep. This is the best example of something steep. Steep means this line. This is the best example of steep line. But if you don't have a steep line, this is like a curved, bending, and like this. If the temperature increases, the resistance is also increases, and then resistance and the temperature will increase gradually, and because of that, we don't get the steep line. We will get this form of graph. Okay, which is just showing the less current. It is showing the less current. How you can say this? The resistance increases because of the temperature increases. As you can see that the voltage is increases, but the current is decreasing. Why?
because the heat is being produced, which causes, which is like oppo- you can say that it increases the resistance,
Hmm.
and then it will oppose more current.
Yes. Resistance is the opposite of the current. So if the resistance increases, current will decrease. Either you can see this. Now this is the line shows. This line shows that these are going downward. Downward. Okay. So let's look about the diode. Because the temperature and the resistance is so much higher. Diodes, on the other hand, are devices that only allow current to flow in one direction. They will provide only one direction. Filament lamp has a random directions, na? It has only one direction in which current can travel, which is why they only show a current. When the potential difference is positive, they do it this by having a really high resistance in the reverse direction. Because whenever you're going to say the direction in the diode, that will be the direction of current, and if you saw that in the reverse direction, that will be the direction of resistance, and that is the same direction of voltage. Okay, so that effectively no current is going to flow in that direction. Okay, so the current is going in that direction, opposite will be the direction of the resistance, and same for the voltage. I hope you get the idea of the Ohm's law and how these things work. Is it?
Yeah.
Very good. Move to the next topic. Yes, only allow current to flow in this one direction, really high resistance. Okay, when the potential difference is positive. Now this is the important points. Maybe the previous one is the presentation, this is the theoretical data. Resistance is the ratio of the potential difference to current. So the resistance is R in ohm, volt in the potential difference or voltage, volts, current in ampere. Ohm is the volt per meter. Resistance is the value in the material that resists the current to flow through it. For a given potential difference, the higher the resistance, the lower the current. And I hope you understood this concept. Is it? Yes, very good. Now the variable, no, this is the type of the basic resistors. Okay, that is a variable resistors, and the variable resistor is used to vary the current in the circuit. And this is rheostat. I use that rheostat in my experiments when I was in my school and college. When we move in upward, it increases. When we move it downward, it decreases. And that shows how current will be increased or decreased in the opposite direction. Okay. Now measuring the resistance of a resistor. And this is a simple experiment where you place the voltage, here you place the ampere and then adjust the current in the circuit by variable resistor. Read the current at the ammeter, read the voltage at the voltmeter. By calculating both of them, you will get the resistor. Okay, I hope you understood. Okay. Now these are the factors that affect to the resistance of the metallic conductor. You asked this question in the previous class that we have to learn the factors. So these are the basic and the very important factors. Okay, so the temperature, that is the most important factor of the resistance. A temperature increases, the resistance of the metallic conductor increases. I am using an example of conductor material. Okay, and this is because the atom in a conductor gain the kinetic energy and vibrate more, which reduces the rate of the flow of charges, and this causes the current to decrease, the resistance increases. And the types of material, different materials have different resistance. Okay, so the least resistance and then higher resistance, that is the better conductor, that is a better insulators. Okay, length of a conductor wire, the longer the wire, the greater resistance. This is also the best example, best factor. If you have a very large length of conductor, the length of the wire is very large, and that will produce a larger resistance. L increases, R increases, L decreases, R decreases. So in that way we can say that resistance has a direct relation with the length. Okay. And the second thing is a cross sectional area of a wire. So the resistance has the opposite with the area. If you increase the area, resistance will decreases. If you decrease the area, resistance will increases. Okay. A increases, R decreases. A increases, R decreases. Okay. Resistance of a wire is inversely proportional to the cross sectional area. Got it? And the further, this is the formula, like further of A is equal to pi r square pi d square by 4. You have I shared it with you. When you have a MCQs, when you have a question in which you have to find the resistance according to the cross section area, that way you will put the value, you can get the value of area. Okay. Now these are the factors. I hope you all are, and these are the factors you already learned in your school. Or do you have any more factors rather than that? Do you have length, cross section area, material, temperature? These are the things. Okay. Do you have?
Yeah, that's good.
Which one?
I'm saying that's good. The school
यही है. ओके ठीक है ठीक है. ये देखें आप लोग किस तरीके से हैं कि एरिया फिर रेडियस फिर डायामीटर. ठीक है, ये फार्मूला बता रहे हैं. आप देखें ये ओम्स लॉ को एक्सप्लेन कर रहे हैं. Ohm's law states that the potential difference across the metallic conductor is proportional to the current passing through it when the temperature remains a constant. V is equal to IR. सबसे बेस्ट एग्जांपल, आपने जब भी ओम्स लॉ आएगा ना तो उसमें तो ग्राफ बना होगा, लेकिन आपको ग्राफ ड्रॉ करना पड़ेगा. तो सबसे बेस्ट एग्जांपल ग्राफ की ये है. और एक्सपेरिमेंट एक्सप्लेन द करंट वोल्टेज ग्राफ और द रेसिस्टेंस ऑफ अ कांस्टेंट रेसिस्टेंस. आपने यहाँ पे वोल्टेज और करंट को फाइंड कर लेना है और आपके पास रेसिस्टेंस आ जाएगी. ठीक है. और V इज इक्वल टू IR होता है. आप ये ग्राफ में देखें जो होता है ना, I बाई वी, ये आपको एक ग्रेडियंट देता है, एक स्लोप की वैल्यू दे रहा है. ठीक है. और I बाई आर भी आपको ग्रेडियंट की वैल्यू दे रहा है. लेकिन जब R इज इक्वल टू V बाई आर हो जाता है ना, वो रेजिस्टेंस का फार्मूला बन जाता है. ठीक है. अब यहाँ पे ये वाला टॉपिक है आपका ओहमिक वर्सेस नॉन ओहमिक रेजिस्टर. आई थिंक इट इज नहीं है. चलें ठीक है. लेकिन इसमें एक्सप्लेनेशन सिर्फ इतनी है कि वो ऑब्जेक्ट्स, वो मटेरियल्स, वो रेसिस्टर्स, वो कंडक्टर जो ओहम लॉ को ओबे करते हैं. ओहम लॉ क्या है कि वोल्टेज इज डायरेक्टली प्रोपोर्शनल टू द करंट. वो ऐसी स्टीप स्लोप बनाएंगे. जो नहीं फॉलो करते वो ऐसी इरेगुलर स्लोप बनाएंगे. ठीक है. इरेगुलर स्टीप स्लोप बनाएंगे. तो स्टीप तो नहीं होगी लेकिन इरेगुलर ग्रेडियंट बनेगा. तो वो नॉन ओहमिक रेसिस्टर्स होते हैं. ठीक है. Everything is clear, Ayan?
Yes.
Do you have any question regarding today's lecture? Okay.